So this question's got a mix of algebra. The first thing it's got to do is factorise, so we're doing algebraic manipulation here. So we've got to factorise this. Now factorise, you look at all terms and see if there's a common factor. If there is, it's going to be a single bracket factorisation, where the outside will be the highest common factor of all terms. So when we look at this, we can see that 3 and 5, there's no common factor apart from 1, so that won't change those two when we divide by 1. But when we look at the e part, we can see e squared. Well, that means e times e, and that's an e, so therefore there's a common factor of e. So outside here we'd be putting e, and then whatever goes in the bracket has to multiply by e to give you back the original statement. Well, to make 3e squared, I'd have to multiply by 3e. E times e is e squared, times by 3 gives me 3 of them, and I'd have to multiply e by 5 to get 5e, so that's going to be 5, and we're adding, so they'll be adding the middle of the bracket there. So we would check, and e times 3e is 3e squared, e times e squared, and then 3 of them, and e times 5 is 5e. So that was what we had originally, and e 3e plus 5. Okay, the next part of this question asks you to solve, so we're having to make k the subject. We've got a bracket, so the best thing to do is to expand that bracket because there's not just one number here to divide by 7. So we'll expand the bracket, so we've got 7k, take away 21. Be really careful when we expand. It's 7 of those and 7 of those, timesing of course, because it's a number next to a bracket. So 7k equals 3k, take away 5. The purpose is that we want k equals. The answer line gives you the clue, so I need the k terms to be on one side of the equals, so I'm going to subtract 3k from both sides. I'm subtracting 3k because that'll leave me with positive k's. If I subtracted 7k, it would work, but I'd end up with negative 7k's to deal with. I much prefer to keep things positive if possible. So 7k take away 3k is 4k, done nothing to the take away 21 yet. 3k take away 3k is nothing, so that's why that's gone. And then we've still got the take away 5. Really important that we keep the take away sign. So we now need to get this over to the other side, so we're going to make this 0. So to do that we would add 21 to both sides, and that's going to give us 4k equals, well, negative 5 plus 21 is 16. And I want 1k, so we divide by 4 both sides, and so k will equal 4. And again, this exam, you spent 11 years doing this, getting ready for the stage, some of you, so it's worth checking that it works. So the idea of this k value is that when you put it into here, the left hand side is the same as the right hand side. So 7, we said that k was 4, so we've got 4 take away 3. Well, that equals 7 times 1, which is 7, so that's the left hand side. And then we have to do the right hand side of the equals, so we've got 3 times 4 take away 5, well 3 times 4 is 12 take away 5, and that is also 7. Okay, so we've got 7 on both sides, so they're both the same, so k is 4. And the next part of this question goes on and asks you to expand and simplify this binomial. So we've got two brackets being multiplied together. There's absolutely tons of techniques for this. Some people like FOIL. I personally prefer the grid, but it really doesn't matter. The grid just kind of lays it out so that I make sure I don't miss anything with timesing. So we've got x times 2x squared. We've got x times positive 3, so positive 3x. We've got negative 8 times 2x, which makes negative 16x, and we've got negative 8 times positive 3, which makes negative 24. We look for like terms to simplify down, because the question said simplify, so we've got a 2x squared, no more x squared to simplify down. We've got 3x's, take away 16x's, which will leave you with negative 13x, so take away 13x, and we've got negative 24 at the end there, so take away 24. So that would be the expansion. We should be checking that it works. So if we give x a value, I'm going to give x a value of 9, simply because I want this to remain positive when I'm doing multiplications, makes it neater. So this is saying 2 times 9 plus 3 in that bracket, 9 take away 8 in that bracket. 2 times 9 is 18 plus 3 is 21. 9 take away 8 is 1, So with a value of 9 for x, these two brackets multiplied give me an answer of 21. So I now check that this gives me also 21. So we've got 2 times 9 squared, because x we said was 9, take away 13 times 9, take away 24. So 9 squared is 81, 2 of those is 162, 13 nines is 117, so we're going to take away 117, and then we're going to take away 24. So 117 and 24 makes 130, 141. So take away those, I get an answer of 21. So my check worked. So I can be quite confident that that answer is now correct. So again, it's worth checking answers to see what happens. So we've got another solve question to do in this one. So a lot of algebra manipulation on this question. Solving with a fraction. So we don't really like things on in the denominator position of a fraction. So the thing to do is, because we want f as a subject, is we're going to get the 4 to the right hand side of the equals. This says divide by 4. So we always do the opposite operations to move things across the equals to go from one side to the other. So timesing this by 4 will leave us with 7 take away 3f. Timesing this by 4 will give us 8. Just remember that 7 take away 3f over 4 times by 4, well, that's the same as timesing by 4 over 1, because 4s can be written as a fraction, 4 over 1. That means we'll end up with 4 bracket 7 take away 3f over 4, because 4 times 1 is 4. Well, those 4s cancel, so that's why you're left with just 7 take away 3f, not multiplying the 7 by 4 and the 3f by 4, because we're dividing by 4 anyway. So we're left with just that, 7 take away 3f equals 8. So we want to get f as a subject, so we're going to subtract 7 from both sides. Being careful that that negative is not being dealt with yet, the takeaway is not being dealt with, so it's take away 3f equals 8 take away 7 is 1. I want f on its own, so I divide by negative 3, because negative divided by negative gives me positive. 3 divided by 3 is 1, so I've got positive 1f. So we end up with f is equal to 1 divided by negative 3. Now when you're doing division, remember you can leave it as a fraction. So 1 divided by negative 3. Negatives on the bottom, not nice, so we tend to put the negative in front, so it becomes negative 1/3. So f here is negative 1/3. Now again, we should really check that this worked. So 7 take away, well, the idea of f is that it goes into the original equation, so that's 3 times negative 1/3 all over 2. So we've got 7 take away, well, 3 times a negative 1/3, well, 3/3 would be a whole 1, but we've got a negative, so it's 7 take away negative 1 over 2. 7 take away negative 1 means we get bigger, so 7 plus 1 becomes 8 over 2. So that answers, no, it was over 4 originally, I don't know why I wrote a 2. So it's worth checking, because I made a silly error there. It was over 4 originally. So 8 over 4 is 2. So our check worked. Okay, so a lot of algebra there, but with a bit of practice, shouldn't be too bad.